Now let's understand the concept of identity, and we shall also see the difference between an equation and the identity. Now let me consider the expression a plus b bracket square, and let me consider another expression a square plus twice ab plus b square. Now if I equate these two, we know that a plus b bracket square is actually a square plus twice ab plus b square. Does not matter what real values of a and b I choose, or what numbers a and b I am choosing. So I am equating here the two expressions, and this equation or this relation is getting satisfied for all values of a and b. All values of what? A and b. Then this kind of relation is called what? An identity. Another example I may give you, sin square theta plus cos square theta. If I consider and if I equate this to 1, this is always true. This is true for what? Any real value of theta. So sin square plus theta plus cos square theta equal to 1 is true for all real values of what? Theta. So it does not matter which theta I put, I always get this combination sin square theta plus cos square theta equal to what? 1. So this is an identity. This is an identity. So identity is nothing but equality of two expressions containing variable or what? Variables, and that equation is getting satisfied for all real values or all values which are present in that equation. Now what is the difference between the equation and the identity? If I consider x square minus 5x plus 6 is equal to 0, this cannot be said an identity, but this is an equation and it is satisfied only for what? Two values of x, not all real values of x. So the values are namely 2 and 3. So if I put x equal to 2 and x equal to 3 in the left hand side, I get left hand side equal to 0, which is equal to what? Right hand side. Therefore x equal to 2, x equal to 3 are the only two values of x which will satisfy this equation. So this is the equation. So equation here, we are equating the two expressions, x square minus 5x plus 6 and that side what? 0. But that is not satisfied for all values of x. It is satisfied for some values of x. Such kind of relation is called what? An equation. Now if I want to say ax square plus bx plus c equal to 0, we know that this is a quadratic equation in x and it has at most two roots. So roots may be of this kind. So this is nothing but what? An equation. This is not an identity. But if at all I want ax square plus bx plus c is equal to 0 is an identity, then it has to be satisfied for all values of what? X. But we know that that is not true. But I want this true for all real values of x, then the necessary conditions are as follows. I must take a equal to 0, b equal to 0, c equal to 0. If I make a, b, c each 0, then does not matter what you put here. So it does not matter what real value of x or what complex value of x you put in this. This is always true. This is what? Always true for all values of x. Such relation is called what? An identity. So difference between the identity and the equation is, it is that relation which is satisfied for all real values of x or all complex values of x. Rather we say all values of x. for it is satisfied, then that relation is called identity, and if it is getting satisfied for some values of x, then it is called what? An equation. So equation is satisfied for some values of x, and identity is satisfied for all values of x, or whichever variables are present in that equation, for all values of those variables of that equation. So this is the difference between the identity and the equation. Now let's solve one example. Let's solve one example based on the identity. Let me choose one relation, p square minus 4 into x square plus p plus 2 into x plus p square plus p minus 2 equal to 0. The question is, what are the values of p for which this is an identity in x? Now, as I said, ax square plus bx plus c equal to 0 is not the equation. If it is an identity, then a has to be 0, coefficient of x square, b has to be 0, coefficient of x, and the constant term has to be what? 0. So if this is the identity in x, therefore coefficient of x square must be 0, coefficient of x must be 0, and the constant term must be 0. Means all these constants are simultaneously 0. So let us equate each to 0 to get the values of what? P. So p square minus 4 I am equating to 0, p plus 2 I am equating to 0, p square plus p minus 2 I am equating to what? 0. This gives me p equal to 2 or minus 2, p square equal to 4, p equal to plus or minus 2. This gives me p equal to minus 2. And here I can get the factors of this, p plus 2 into p minus 1 equal to 0. That leads to minus 2 or 1. But I said all these things simultaneously 0. If this becomes 0 and that does not become 0, then this cannot be said the identity. A, B, C has to be 0, each equal to 0. So here all of them are 0 possible if I choose the common values. Now here the common value is what? Minus 2, because it is present here also and it is present here also. So if I choose p equal to minus 2, then this becomes 0, this becomes 0, this becomes 0, and it reduces to the form 0 into x square plus 0 into x plus 0 equal to 0, and that is true for all values of x, whether they are real or complex. So we can say this would be the identity if p becomes what? Minus 2.